Good afternoon, everyone. I'd like to welcome you all to An Inconvenient Truth, User Attitudes Towards Security and Usability Trade-Offs for Key Directory Encryption Systems here in Mandalay, BCD. Speaking with us today is Professor Patrick Kelley. He is a professor at the University of New Mexico. A couple of little housekeeping tips here. You can still stop by the business hall in Bayside A and B. And if you haven't picked up any merchandise, the store will be open until 6 p.m. tonight. If you would now, please put your phones on vibrate or silent, and welcome Professor Patrick.
Okay, great. So this is supposed to be a 25-minute talk, but I have been informed that I have an hour-long session with nothing after me, which means that they can let me go on really forever. I'm not going to do that to you because I realize that this is the very last thing. And so I'm going to aim for speaking for about 20-25 minutes, and then we'll have plenty of time for questions if people want to stick around. If not, you can head over to the store before they close. I hear everything is on sale right now, so you should probably check that out. This is joint work that was done with a team of students at the University of New Mexico and the University of Maryland, with my colleagues there. And this was first published this summer at SUPS, the Symposium on Usable Privacy and Security. This is a conference that is completely focused on issues of human factors in privacy and security. Every paper that is published there has to have some element of a human study and also some element of security or privacy. So, what is end-to-end encryption? Just kidding, I'm not going to talk about what end-to-end encryption is for this talk before you all leave the room because it's the last thing on the last day of Black Hat. You know what end-to-end encryption is. You know that end-to-end encryption is important because if you actually can encrypt things end-to-end, then you are protecting yourself from all sorts of malicious actors, from hackers, from governments, from misbehaving employees, from companies that you don't trust, from others who you are concerned with protecting your information from. But this talk is not for you or necessarily about you. This talk is about what real humans think about encryption, which means that we had a series of participants who took part in this study. We had 52 of them. They were between the ages of 18 and 34. They were about half male and half female. About 40% had jobs in computing, math, and engineering, but these are not security experts. These are not people who think about security. They might be slightly more technical or slightly younger than a general population, but they are not people who are focused on privacy and security. In fact, we measured their security expertise using a scale that was developed by researchers at the University of Indiana Bloomington, and only 2 out of 52 scored a 3 or higher on this scale. You might say, how do you measure security expertise? Well, we were using questions like, have you ever registered a domain name? Have you ever created a database? Have you ever used SSH? Have you ever configured a firewall? Or questions that asked our participants to describe what a security certificate is, or to describe what phishing is. This is not questions that are as technical as most of the talks that you probably attended at Black Hat, but these are still questions that our participants couldn't answer for the most part. These are not experiences they had. The people that we worked with in this study that I'm going to talk about are regular people. Regular people out in the world who probably have never heard of Black Hat and don't really know what it is. And what we wanted to understand is if people, real people out in the world, could understand encryption. And specifically, if they could understand various encryption schemes, right? Not all encryption is created equal, and many of you know that. In fact, if we think about encryption on this 2-axis oversimplification of how encryption works, then we can think about how secure some form of encryption is, and how easy to use it is. Which means in some magic ideal world, we have something up here that's incredibly secure, again measured on some non-existent axis where I'm not really measuring the security, but I'm saying this is very, very secure, and it's also very easy to use. Anyone can do it. You can do it, but also these people that we're talking to in our study can do it. This might not be what we have today. What we have today is probably some things that are closer to this. Maybe what we're calling an exchange model of encryption. Something similar to PGP. Something where you have 2 people and they are creating a private key and a public key. And in our study, when we talked about these models to our participants, we described a public key as a public lock. This was again based out of earlier research that was published in 2014, Why King George III Can Encrypt. And it actually looked at using different terminology and different metaphors for encryption to try and understand what people could really get a handle on. And if any of you ever considered why all of the encryption schemes we talk about have only keys and no locks, you probably haven't thought about that. But it turns out if you work with people and they think about public locks, then they get a better sense of what to do. So they create their private key, they create their public lock, and then they somehow exchange their public locks out of band, right? They transfer them over some other channel. This is how PGP works. This is a system where users have to manually do this lock exchange, and they shouldn't really mess it up. And many of them do, and we know that. And that's why this system on our graph is quite secure, but it's not particularly easy to use. And we've known it's not easy to use since the late 90s. We also might have another system, a registration model, for example. Something similar to the way end-to-end encryption for Gmail works or iMessage, where a central server is managing all of those, again, as we're calling them today, public locks. Now, I'm not exactly sure where you would place this on this chart. You might argue about how secure it really is, if you really can trust the centralized provider, or how easy to use it is. I think you might all agree that it's easier to use than something where you have to manually exchange those locks. But again, these axes aren't labeled, so I'm not saying how much more secure, less secure, how much easier to use or less easy to use it is. But that's how this system works, right? Instead of doing that lock exchange manually, the centralized email server takes care of it. It distributes those back out to the users, and for the most part, they never see it. Now, again, I don't want to put words in your mouths, right? You are the security experts here, and you may or may not trust these sorts of systems. And depending on your threat model, you might have good reason not to trust these systems. You might be worried about governments trying to compromise the information of these centralized providers, either through warrants or through other means. You might be worried that the centralized providers, the companies who are running these services, shouldn't be trusted to begin with. But what we wanted to know, and again, the main focus of this, is how do general users perceive the security and usability of these systems? And can we explain these systems to people? So to get into the weeds of the methodology here, we recruited participants through email listservs, through flyers around campus, through postings on Craigslist. We brought in 52 participants, like I said, and we had a within subjects design, where they had a first model and a second model. They either saw the exchange model first or the registration model first, and half saw each, so that there wouldn't be any biased effects around which one they saw first. We used a plugin called Mailvelope that we modified so that there was a very, very simple interface that our participants could use, and one that we modified so that the exchange and registration conditions were very similar. We walked our participants through a series of tasks. So first, they had to generate or register their public lock and private key pair. And I'll come back a little bit at the end to what it meant for participants in the registration condition to do this. If you're familiar with using one of these registration systems like iMessage or WhatsApp, you don't actually generate your lock, right? This is all taken care of completely invisibly to the user. You don't actually see that transfer happen. But in our study, we actually did have participants click a button to actually do that registration, so that they were actually aware that that encryption was happening and taking place. They then had to exchange a single email with Alice. They needed to exchange a lock with Alice to begin with so that they could successfully encrypt the email in the exchange condition. They then needed to exchange emails with Bob and Carl, two other participants. All of this was done with a Wizard of Oz approach, which means they weren't emailing real people, but rather they were emailing our lab assistants, who would then email them back so that they could tell that this was working or not working. They then had to imagine exchanging email with 10 more people. We didn't actually make them do that exchange 10 more times and actually send 10 more emails, but they had to think about it. They had to consider it. And we then had them walk through and think about misconfigurations. So for example, what would happen if they lost the person they wanted to communicate with public lock? What would happen if they lost their own private key? What would happen if they accidentally publicized their own private key? And again, you might think, who would ever publicize their own private key? But this is something that happens, right? These are real misconfigurations that happen to people out in the world. They also did a series of steps where we actually had them learn about the security of these different models. So for the exchange model, they again got to think about how this could happen. What could a possible security attack, what could a possible attack be? And we walked them through some of the steps of how this could happen, of how someone could compromise emails that were encrypted in this way. We did the same thing for the registration model, specifically talking about what would happen if they did or didn't trust the provider. We also actually looked at two variants of the registration model. One, which is confidentiality as a service, something published, again, in the academic research, where instead of having the, again, public lock stored just with your email provider, the lock is actually split up and stored between multiple services. This could be just one service, this could be multiple services. And so for the lock to be compromised by the central trusted provider, you would actually need to have all of them colluding, or you would need to have an outside entity who can actually work with all of those parties. We also had them think about an auditing model where the locks are stored in the centralized server, but various devices or external auditors or other third parties can verify the locks and do so using a specific protocol that allows them to check in to those locks at a somewhat systematic basis. Now, I'm not going to get into the details of either of those two schemes today, and there's more about that in the paper if you're interested, but we did try and explain it in basically the same terms that I just used to our participants. And you might say, this is ongoing academic research, right? These are papers that have been published within the last 3 years. These are ways that people right now are thinking about how we can make these registration models more secure, how we can actually help them not just trust one single point of failure. But we were able to explain these to our participants, and we'll come back to what that means at the end. Just as a reminder, again, these were our participants, right? 52 people who looked at these different schemes, who looked at the models. They spent about an hour with us, and we paid them with a $15 gift card. Our analysis here, we did both a quantitative and a qualitative analysis. So the results you'll see over the next few slides include both responses to survey questions that we asked our participants, which we did a cumulative link mixed regression model on, and also a qualitative analysis, where we had an open coding of 2 researchers who looked at all of the things our participants said, just the feedback they had as they were going through this process. When they said, oh, this isn't very secure, or I wouldn't trust this, or I wouldn't do that, right? We had people independently code those results so that we could actually look at what people said, what they said outside of this, and how their experience really was. So what are our results? Well, first off, we asked participants if sending and receiving encrypted email to 10 people, so again, this is the one that they thought about but didn't actually do, would be difficult. And where we define difficult as intellectually challenging. And what you see here is a whole lot of orange, which means our participants disagreed. They didn't think this would be difficult. They thought they could do it. They thought, this is a thing I can do. And many of you might say, well, okay, but maybe they're just saying that. Maybe they think they're smarter than they are. Maybe they could actually do this, but they don't. But our participants believed that they could. They believed that this was a thing they could do, almost all of them. Again, only 2 participants strongly agreed that this would be a very difficult thing for them to do. Difficult, again, as in intellectually challenging. But we then asked our participants, the same question about that 10 people, would this be cumbersome? Would this be tedious? And here, you see much less orange. In fact, for the exchange models, you see that almost everyone said that this would be a tedious task. That in fact, this would be cumbersome. This would be a hassle. And we know that people are not using PGP-like systems to encrypt their email. We know that most emails are sent in the clear, and that's even after you factor out all of the spam. We know that these emails are being sent out, and we agree with this. People are, in fact, not encrypting their email. And here, our participants are saying it's not because it's too hard, but it's just because it's too annoying. If you look at the registration model, you'll see more mixed results. You'll see people here saying, this is a system they could do. They could handle the registration model. They could handle doing almost nothing to encrypt their emails. And this is a logical and maybe common sense result, right? You might expect this. So we know that the exchange model was dramatically more cumbersome and somewhat more difficult, slightly more difficult. Our participants once said, the exchange model is time consuming, especially sending urgent emails. I have no choice but to wait for the correspondence public lock, right? They understood that this was a real thing they would have to do. What if I don't have the lock set up? What if this isn't all already enabled? I have to sit there and wait. What if it's important? We also asked our participants to think about the security implications of these different systems. And it turns out the perceived security gap is small. Now, this goes back to that chart I was showing at the beginning with those axes of which one of these systems is more or less secure. When you talk to security experts, it sounds like Exchange is a lot more secure. But when you talk to users, when you talk to general people who are out there and who should actually be encrypting things, they seem to think that, in fact, there's not that much difference in the security of these two systems. Specifically, they believe that the manual effort in the Exchange system will lead to vulnerabilities. This might not be true for us. We might understand how we need to save and secure our private key. We might know when to distribute our public lock and make sure that people have a copy of it and can find it and can access it. But the participants in this study believed that the manual effort involved in setting up this system would lead to their own errors. They believed that they would make mistakes and that it would make the entire system less secure. For the registration model, they understood the concerns. They understood that they had to trust their provider, but they said that they generally did. And they thought that since it was all handled automatically, they thought the system was about as secure. So we saw a very, very small security gap. And if we look at that in numbers, the blue here is people saying that this model protects my privacy, right? And again, you'll see almost all blue. A little bit more on the Exchange model, especially if they saw the registration model second, right? And so this is what I was talking about earlier when I said we counterbalance to make sure people saw one first and the other half saw the other first. If they saw registration second, so if they saw the generally more secure system first, then they said, oh yeah, this one maybe doesn't protect my privacy quite as well. But overall, most of our participants still felt both of these systems protected their privacy. If we summarize that, 48 out of 52 of our participants trusted the Exchange model. Only 4 said that this wouldn't necessarily protect their privacy or they weren't willing to commit either way. Only 38 trusted the registration model. And again, the order played a significant impact. This was a statistically significant result where participants who saw the registration model first were more comfortable with it, and participants who saw Exchange and then registration were a little bit more concerned with registration. If we come back to that finding before, again, we saw that the manual effort may lead to some of this vulnerability. The reason why participants are saying this was that manual effort. More than half were concerned about how to get that other person their lock. More than half were concerned about messing something up in this process. One participant said, there are too many exchanges between different people. Exchanging these locks to everyone, something could go wrong. When we looked at the concerns around registration, again, it was generally trusted. 10 participants came out, and this wasn't a question we asked specifically, so this isn't 10 out of 52, but 10 of our participants in the discussion just said, yeah, I trust my email provider, right? They trust their email provider. They think that they're going to protect them. 7 participants were specific about who they'd trust. One person said, big companies like Google and Yahoo don't do such things, referring to violating users' privacy, unless the government forces them to. In general, it's secure. You can disagree with this if you want. When we look at the more specific registration models, these registration models that add a little bit of privacy or security, we had some of our participants who really liked this. One said, in the CAS model, if one party is screwed up, you have another one to protect your email. You're still safe, right? And so they understood that this added, the adding people to these systems was adding a little bit more security. We also had someone say about the auditing model, obviously it's extra secure because other parties are verifying it, right? They understood that there was this extra helping hand, this extra person watching out for them, and they liked that. Though others actually had some concerns. One person said, in this model, involving more systems may complicate the system, right? Just like they thought in the Exchange model, if you have all of these multiple exchanges going on, things may get more complicated. They thought, well, having multiple people with multiple parts of your lock might actually complicate something. And it's possible that it could. We haven't seen these systems implemented in a large-scale way. One participant also said, I want to know who these auditors are, their reputations, and whether they are truly independent. They wanted to understand if they could trust the auditors or if this was just one more set of people that they wouldn't really be able to trust, still thinking that the Exchange, because they do it themselves, might be the more secure method. We also asked our participants to rate their willingness to use this model in the future, right? This is the big question. Most people out in the world are not encrypting their communications, certainly not if they have to take extra steps to do so. And so we said, would you use these systems? You know about them now. We sat you down, we talked to you about them for an hour, we had you use this system in our lab. Would you go out in the real world and use this? And we saw very mixed results, and mixed results across the board for both, right? We saw participants who some said yes, they would, and maybe they were just trying to make us happy. We know that that's a possible bias in this type of research. We saw others who said, no, I wouldn't use this. I'm still not going to use this for a variety of reasons. And we saw no significant difference between the two models. Neither one of these left our participants saying, oh yeah, they would definitely do this. We asked them when they would use these models. For the registration model, they definitely said they saw more broad use here. 15, and again, this is something they came forward and said to us, this wasn't a question we directly asked, said they would use this in general email or in a large-scale way. They thought that a registration model was something that they would be happy to have on for most of their email. For the exchange model, most of our participants who said they would use this at all said that they would only use it on a small scale. They would only use it for specific people who they wanted to, for example, send high security information to. We had, of all of the people in the exchange system, only one who said they would use this generally. And no one said that they could see themselves using this model on a large scale. No one said they could see themselves trying to encrypt all of their emails with a system like this. We also talked to our participants about handling misconfigurations. We asked them a series of questions that I don't have time to get into today, but I will give one example about how they would handle if something went wrong, right? And we saw that 3/4 of our participants got all of these questions right. And again, this was done through that coding of independent researchers. This wasn't a multiple choice type of situation. This was something where they gave us answers verbally that we thought were correct. And another 13% were largely correct, right? They might have said a couple things that wouldn't have helped protect themselves or that would have actually been a little bit wrong, but they largely understood how to handle most of the misconfigurations they might be faced with. Only 12% fell into some other category where generally they either sort of were totally wrong or they gave up or they decided they just didn't know what to do in these situations and they would have to ask someone else for help. This is a good example that people could actually deal with these systems, right? They seem to be able to reason about how to actually use them. One of these examples was what would happen if you were losing a private key, right? If you lost your private key. One participant mentioned that they would recover the keys from a backup, thought it might be a good idea to make a backup in the first place, put it on a USB drive or another computer. Another participant said, I would send my email to a third person that I trust and ask that person to encrypt the email for me and send to my recipients. Then that person will also decrypt my email for me and send them back. This is one of those answers where clearly there's something going wrong here, right? This person understood that possibly having the emails encrypted in the first place was a good idea, but also was totally okay with sending those same emails in the clear back and forth to this third person who has the terrible job of encrypting and decrypting all of this person's email, which is a very good friend, but possibly not the best way to fix this specific problem. But we saw that our participants were willing to reason with these things. And participants explicitly made trade-offs about security and usability features. So we had one participant who said that he would not use the exchange model because the negotiation process that gives me safer feelings, more protection, but on the other hand, it's time-consuming, it's cumbersome, it's tedious, it's more complicated, and this is the price I have to pay for more protection, right? This person understood that they were deciding not to use a thing that was more secure. But they were dealing with those trade-offs. They were saying, this is too much hassle. This is the same type of thing that many of us probably do when we decide that we're not going to encrypt all of our communications. So if we step back and look at this at a broad level, we believe that it's possible to explain the high-level concepts and risks of encryption to users, right? We have possibly heard for years that people out in the world are just never going to understand encryption. They're not going to get it. They're not going to be able to do it. It's a lost cause. But when we had participants sit down in our lab and we talked to them about the security issues, the different systems, the ways things can be misconfigured, it really seemed like they were understanding what was going on, that they were making, for the most part, good decisions, that they understood the trade-offs, and that they also understood that there were real reasons why they weren't using these systems. If we find that if you place users in that context, you can, to some extent, trust their decisions, and that they can think about these trade-offs effectively. We also, again, want to point out that people believe that the registration model is more convenient than the exchange model. And the perceived security gap is small. And so if you disagree with that statement, if you think that the security gap here is very large, then this might be a place where more of that education is important. It's obviously very hard to come up with a good way to measure the security of these two systems in some objective way. But right now, users who actually spend time thinking about these systems decided that the security gap is small. And if that's something that we as a community need to correct, then it's something that we should think about ways that we can message that out to people. Also, we want to point out that we used what we believe is a relatively best case method for explaining encryption, right? We had people in our lab. We talked to them one-on-one. We had them looking at diagrams and reading instructional materials with us sitting there while they were doing it, and we were paying them. This is not going to be the general case for most people who want to go learn something about encryption. There's certainly lots of resources out there online, but that doesn't mean they're going to read them. That doesn't mean they're going to be paid to read them. And so we understand that there are some effects here that are specifically because this is such a good case. And we think that's okay. We think it's fine that in these situations, people can really understand encryption and can understand the trade-offs between these two different systems. Now, the message for you is that there is hope. I am convinced there is hope, and I want you to be convinced there is hope, that we really can help people understand encryption. We can help them understand these trade-offs. And there's certainly a lot more work to do. Like I mentioned at the beginning, when we did our registration model, participants actually had to click on a button to generate that public lock. They actually got to see a little animation that made it look like their message was encrypted. If you're using a system like iMessage or WhatsApp or Facebook's now secret conversations or some other system that does a registration model, it is almost always invisible to users. We don't know if that provides the same security benefits in a perceived way to users. We don't know what that means in terms of the way they think about encryption, or if they even know their communications are encrypted, or if they even need to. But we still think there are ways that we can reach out to them. We think this is important when you're designing encryption systems, and we think that there is still benefit in education. So with that, we're right at the end of the 25 minutes. If people need to leave, you're welcome to, but I'd be happy to take questions with the rest of the time in this session. And I again want to thank my colleagues at the University of Maryland and thank all of you for coming.
Point that in the government space, they have a multi-million-dollar or multi-million-user registration email system in place. Yeah. I don't know if that's useful to your research. But the question is, having come from the government space, do you end up asking any questions about key management or token management?
So we didn't really push them very far on sort of long-term key management solutions. We really wanted to get them thinking about, because most of them don't do any sort of key management at all right now, we really wanted to get them to think about how they would start with this system, how they would even sort of get started, how they would talk to just a few specific people. Yeah, but thanks. Anything else? Well, thank you all so much for attending, and enjoy everything else. Enjoy whatever conference is next if you're heading over to DEF CON. And I'm happy to talk to people after the talk. Thanks.